parenthesis greater, approaching to the right. Now it's really up to you. You can solve this, graph first, and then find this interval notation. And find this answer in interval notation is up to you. So depend on what works for you. Sometime after I saw this inequality and I got the answer right here, right? And sometimes it's easy for me to graph first. And from graphing, I can see it, I can visualize, I can see, I know, oh, it's approaching to the left. So they've got to be negative infinity here. And -1 right here is the right end point. And I'm not including it. You've got to be parentheses, right parentheses. And same thing, I'm not including, there's no solution right here. So it's union, mean this or this. So I use a union right here with, what is that? X greater 1/3, right? Greater. So approaching to the right infinity. So it's got to be positive infinity right here. And for positive infinity, it's always parentheses because we don't know exactly what number it is. And 1/3 right here is the left end point. And it's got to be parentheses because greater than, mean we're not including it. So this is the example. And I have one more example. In the next space. Same question. I asked to solve and graph. And let's say I'm asking you from now on write the answer in interval notation. Now I could ask you to write the answer in set notation as well. So make sure you review the previous section where I cover that. Now for this case, given the inequality, we can solve this. So this is an inequality that involves absolute value. So which one is that you will use? Now, remember, I like to write the absolute value on the left. There's only one coefficient, which is 1, okay? Coefficient 1. So this time we have the absolute value on the right. Let's rewriting it, keep it on the left. 2x minus 3 plus 9, right? If I write this right-hand side right here to be on the left, and this 16 on the right, so how about this inequality? Do you see that this absolute value is greater than 16? You see that? It's greater. So make sure you write greater than 16. Okay? These two are equivalent. You can write this on the left and this on the right. And make sure you still write it correct. Make sure you still maintain the correct inequality symbol. It would be wrong if you keep it this way. It would be wrong if you use this for this one. It's wrong because based on this right-hand side right here is greater than or equal to. Okay, so now it would be wrong if you go ahead and using this rule right here to start solving it. Okay, because you still have this coefficient right here. Sorry, you still have this constant term right here. This rule applies when there's no constant terms added to the absolute value. Okay, there's no constant terms added to this absolute value. So make sure you eliminate this constant term first before you use this rule for this condition. So I need to eliminate plus 9. How do I do that? Using the addition principle, right? Subtract 9 on both sides. Okay, I just subtract 9 on both sides. Simplify 2x minus 3 9 subtract 9 is 0. 16 subtract 9 is what? 16 subtract 9 is 7, I believe. Yep. So 2x minus 3, x value plus 0 is just 2x minus 3, 7. Now, do you see that it becomes one of these four, right, where the left-hand side is the absolute value only. There's no coefficient. There's no constant. There's no constant added to the absolute value. And the coefficient is 1. Okay? This is what we want to obtain. There should be no constant added to it. If there is, when you solve it, you make a mistake. You won't get the correct answer. So make sure, if it's given like this, make sure you take out, remove the constant using the addition principle. So now I can use this rule, which is absolute value greater than p, which is 7. That means I'm going to solve two equations. X to the inside, 2x minus 3 less than or equal minus p, which is 7. And the inside is 2x greater than or equal p, which is 7. Okay? To solve for x, we need to add 3 on both sides. So we can remove the negative 3 term. 2x minus 3 plus 3 is 0. Negative 7 plus 3 is negative 4. So 2x plus 0 is 2x, less than or equal to negative 4. We can solve for x by divide by 2 on both sides, and multiply 1/2 on both sides. So 2x. Now, if this is inequality, again, you need to be careful because we divide 2, which is a positive number, so we maintain the inequality. Simple. 2x divided by 2, which is x. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. Okay? So got that. For this inequality, similarly, we need to solve for x. So we solve for x by adding 3 on both sides. To remove this constant term, 2x minus 3 plus 3 is 0. 7 plus 3 is 10. 2x plus 0 is 2x, greater than 10. Divide by 2 on both sides, or multiply by 1/2 on both sides. So I'll do the alternate way. Now, before you write out the inequality, again, make sure what you just multiplied and see if it's positive or negative. Since we just multiply 1/2, right, on both sides, it's a positive value, so we keep the inequality. We have the same inequality. Simplify 2 on top, divided by 2 at bottom, which is 1. 1 times x. 10 on top, divided by 2 at bottom, which is 5. 1 times x is x, greater than or equal to 5. So we have here E2 that represent solutions of this inequality. Alright, to make space, I would need to erase this, so I'll give you a moment to see it. Right? So for part A, we have x less than or equal to negative 2 and x greater than or equal to 5, and it is OR, okay? Alright, write the answer in interval notation, so that means you need to use bracket or parenthesis. And part B is graph. Again, let's do the graph first. So it's up to you if you like to graph first, but don't forget to write the answer right here. You can graph this first. X less than or equal to minus 2. So negative 2 here, 5 right here. So x is less than or equal to minus 2. Less than or equal means including, right? So will you bracket for this case? Will you brackets at this right hand point, which is negative 2, less than, okay? For this, x is greater than or equal to 5. Greater than or equal to mean we're including it. When we're including it, we use the bracket. Because this is the left endpoint, I use the left bracket. Bigger, right? So extend to infinity right here. So this is the graph. Now, let's go back to part A. Can you use the graph to write the answer in interval notation? Do you see this extend to the left, right? So it has to be negative infinity. Okay? And because we don't know what the infinity is, we use parentheses, the left parenthesis, for negative infinity. The right endpoint is negative 2. Since we're including it, we use bracket. And then this is union, because R, with solution right here, starting with the left hand point, including it, bracket 5, extend to the right, positive infinity. And then for infinity, it's always parenthesis. For positive infinity, we use the right parenthesis. Okay? So let me see any more example we have. So up to now, these are our example for number 6, inequalities with absolute value. So by this, I'm finished covering section 1.6, absolute value equations and inequality. And let me show you the homework list. Okay, check this out. For sections 1.6, going to be 1, 3, 7, 13, 15, 1, 3, 7, 13, 15, 19 to 33 odd, 37, 43, 47 to 53, 57, 59, 63, 71, 73, 77, 89, 95, 97, and 103. Let me verify. 1, 3, 7, 13, 15, 19 to 33 odd, 37, 43, 47 to 53 odd, 57, 59, 63, 71, 63, 77, 89, 95, 97, 103. So this is homework list. And as usual, I don't collect homework. But it's important for you to practice this because it prepares you for the quiz and the midterm and the final exam. So make sure you review my lecture now carefully, watch the video, combine the two together to understand the concept of the class, and work on the homework will help you for the class. And I'll see you next time for the next section.